This is Module 6, Section 2.2. In this section, we're going to look at solving linear equations also using properties of equality. But in this section, we are going to emphasize the multiplication property and the division property of equality specifically. And again, we're going to look at opposite operations. In this case, multiplication and division being opposites of one another. For Section 2.2, we are going to start with the last two properties of equality, which we introduced in Section 2.1. The first property said if A is equal to B, then if you take that equation and now instead of adding or subtracting, you multiply some value to both sides, you still get a true equality as long as you multiply both sides by the same thing. In a very simple example, let's say that you had this equation, 2 plus 3 equals 5. You would agree with me that 5 is equal to 5 on both sides. If you decided that you needed to multiply both of those sides by, let's say, 2, your equation would become 2 times that 2 plus 3 group is equal to 2 times 5 on the right-hand side. Now on the left-hand side, since we have numbers, we could just simplify in the parentheses, or we could use the distributive property if you'd rather. Either way, though, here you're going to get 2 times 5 on the left-hand side is equal to 2 times 5 on the right-hand side. Obviously, 10 is equal to 10. Looks good, checks out, as long as we multiply both sides by the same value. All right. The second or fourth property, if you think about it the way we ordered it in Section 2.1, is the property of division, which says if you have any equation, if you divide one side by a value, you must divide the other side by the same in order for the equality to remain true. Notice that division is the same as multiplying by the reciprocal. And to prove that, if you had, let's say, 12 and you decided to divide it by 6, that should be the same as or equal to taking that 12 and multiplying by the reciprocal of 6, which is 1/6. If you do the math there on the left-hand side, 12 divided by 6 is 2. Over here on the right-hand side, if you remember our review of fractions, you can write 12 as 12 over 1, and then multiply that by 1/6. That would give you, multiply the numerators, 12 times 1 is 12, denominators 1 times 6 is 6. And again, 12 divided by 6 on the right-hand side does give you 2, just like we had on the left-hand side. So divide or multiply by the reciprocal to both sides. Again, we want to use properties of equality to isolate the variable on one side of the equation with constants on the other side, just like we were doing in Section 2.1. And to isolate the variable, we will use opposite operations. For now, we will only need to remember that multiplication is the opposite of division. All right, so let's look at some examples. Let's say you were asked to solve for y. 3y is equal to 12. Notice that 3y can be rewritten, if you wanted to, as 3 times y, because if there's no operation written in between the constant and the variable, it's understood multiplication. We just talked about isolating the variable. We want that y by itself. So to isolate that variable, we need to get rid of the 3, which is being multiplied. According to opposite operations, the opposite of multiplication is division. So if you would divide both sides by 3, both sides because of properties of equality, notice on the left-hand side, what you get is 3 divided by 3 is not 0 like it was when we were talking about the addition and subtraction properties. Instead, it's 1. Anything divided by itself is 1, so instead of getting 0, we now have 1 times y, which is good, because 1 times y does leave you with the y. That's what you're trying to solve for. If 3 divided by 3 gave you 0, you would have 0 times y. 0 times anything is 0. Your y would be gone. And so it's important to remember that with division, you don't get a 0, you get a 1, but they still do, in shorthand notation, they do cancel themselves out because 1 times anything is itself. Right-hand side, 12 divided by 3 is 4, and we get a solution for this problem of y is equal to 4. As always, you would like to check your answer in the original problem. So the original problem was 3y equals 12. We're going to take that 4 and put it in for the y. So now our problem is 3 times 4, and since this is a check, the question is that equal to 12? 3 times 4 is 12. 12 is indeed equal to 12. Looks good, checks out. Another example, x divided by 7 equals 3. Not sure where that other problem went. That's kind of odd. X divided by 7 equals 3. I'm going to rewrite that as x divided by 7 equals 3. All right, we're interested in solving for x. So notice that this is a division problem. You also could rewrite this, if you really wanted to, as x divided by 7 equals 3, although we rarely see it like that. What we want to do now is to use an opposite operation to get rid of the division by 7. Okay? Division by 7 can be removed by not dividing but multiplying both sides by 7. Opposite of division is multiplication. The reason that works is our 7s will cross cancel here. 7 divided by 7 is 1. So we're left here on the left-hand side with 1 times x equals 3 times 7 is 21. Or 1 times x, of course, is x. X is equal to 21. All right, to check that answer, we want to take the original problem. X divided by 7 is equal to 3. We're going to put 21 in for x, so we get 21 divided by 7. The question is that equal to 3? Well, 21 divided by 7 is 3. So 3 is equal to 3. Looks good, checks out. I think we're accurate on that problem. All right, so let's look at this example. Negative 32 times x is equal to 64. We want to get the x by itself, isolate the x. So to isolate that x, we want to get rid of the minus 32 that has understood multiplication with the x. The opposite of multiplication is division, so we're going to divide both sides by negative 32. Negative 32 divided by negative 32 is 1. So we've got 1 times x on the left-hand side. 1 times x is just x. Right-hand side, 64 divided by negative 32 is negative 2. And since our x is isolated, that is our solution, we think x is negative 2. To check your answer, always check it in the original problem. The original problem is negative 32x is equal to 64. We're going to put that negative 2 in there. Negative 32 times negative 2, is that really equal to 64? Do the math on the left-hand side. Negative times negative is positive, and 32 times 2 is 64. So positive 64 is equal to positive 64. Looks good, checks out. All right, let's look at this next example. X divided by 9 equals 1/2. If we rewrite that so that it looks clearly like a division problem, x over 9 equals 1 over 2. Here we want to isolate the x, so we need to get rid of that division by 9. So we are going to multiply both sides by 9. Opposite of division is multiplication. Recognize that that 9 can be written as a fraction if you want. Just write it as 9 over 1. Here your 9's cross cancel out from our review of fractions, or you can think about it as 9 divided by 9 is 1. and 1 times x is just x on our left-hand side. Right-hand side, do the math. 1 times 9 is 9. 2 times 1 is 2. Reduce that fraction if you can, or you can write it as a mixed number, but rarely in algebra do we write these as mixed numbers. So this is our solution. X is equal to 9/2. Do a quick check over here. We've got x over 9 should be equal to 1/2 when we let x be equal to 9/2. So that would give us here 9/2 divided by 9, we think, should be equal to 1/2. Let's look at this right here. 9/2 divided by 9 could be written in horizontal form. So 9/2 divided by 9 is the same as 9/2 divided by 9 over 1. Flip and multiply. 9/2 times the reciprocal is 1/9. Our 9's cancel out. 9 divided by 9 is 1. And we get 1/2, which is the same thing on our right-hand side. So that also looks good, checks out. I think we can feel confident that we've got the correct answer there. All right, I'm going to pull up both those examples and see if we can keep that first example from disappearing when we go to the next example. All right, looking at that top example, we've got 3/4 times x equals 9. We're trying to solve for x. Now, there's a couple of different ways you can do this problem. We're going to do it the longhand once, and then we'll do it the shortcut method that I know your textbook or your ebook, if you're looking at your ebook, describes to you. Notice that as written, this does look like it's a multiplication problem. We've got a fraction times our variable, and so the opposite of multiplication, as we've been doing in previous problems, is division. So one way to do this problem is we could divide both sides by 3/4, which would give us, much the same as what we had before, anything divided by itself cancels out. 5 divided by 5 is 1. 4 divided by 4 is 1. 3/4 divided by 3/4 also is 1. So on our left-hand side, we're left with 1 times x, or just x, on our left-hand side, and our variable is isolated. Now on our right-hand side, we're going to rewrite 9 divided by 3/4 in horizontal fashion. 9 divided by 3/4 is the same as 9 over 1 divided by 3/4, which is the same as 9 over 1 times the reciprocal, so flip that second fraction over. 9 over 1 times 4 thirds is equal to, if you want to do the math and then reduce, 9 times 4 is 36. 1 times 3 is 3, and 36 divided by 3 is 12. An alternative way to do that, remember, from our fraction review, is because this is multiplication, there's a common factor of 3 across the diagonal here, so we could take a factor of 3 out across our diagonal. 3 divided by 3 is 1, 9 divided by 3 is 3, and then we're left here with 3 times 4 is 12 over 1 times 1 is 1, and 12 divided by 1 again is 12, which is what we got here as well. So either way, we find that x is equal to 12. We'll do one more check here. Quick check of that problem says that if 3/4 times x is equal to 9, and we think that x should be 12, we'll get 3/4 times 12 equals 9. Make that 12 into a fraction. Notice that you can cross-cancel if you want. 4 divided by 4 is 1. 12 divided by 4 is 3. And if we do the math up top, 3 times 3 is 9. Over 1 times 1 is 1. 9 over 1 is 9. 9 is equal to 9. The shortcut to that problem is this. if you have a fraction that is being multiplied to your variable, notice that as you do these steps, what you eventually do is you end up multiplying both sides by the reciprocal of the fraction. So a shortcut way to do that problem would be this. We've got 3/4 times x is equal to 9. Look at the fraction that is being multiplied to the variable. Don't look at any fraction on the other side of the equation, just the fraction that's being multiplied to the variable. And the shortcut way to clear that out is to multiply both sides by the reciprocal of this fraction. Remember, reciprocal is just flipping the fraction over. So the reciprocal of 3/4 is 4/3. We're going to multiply both sides by 4/3. The reason that works is notice that your 4's cross cancel, as do your 3's. If everything cancels out, you're left with a bunch of 1's. 1 times x is just x. Right-hand side, 9 times 4/3, if you make that 9 into a fraction and then cross cancel. 3 divided by 3 is 1, 9 divided by 3 is 3, and 3 times 4 is 12. Same answer, shortcut method. So let's look at this example. 2/3 times y is equal to 5/6, and use that shortcut. Okay? You can certainly do it longhand if you want. Look at the fraction that is being multiplied to the thing you're trying to solve for, in this case a y. Take the reciprocal of that fraction. The reciprocal of 2/3 is 3/2, and multiply both sides by 3/2. Now on your variable side, your numerator and denominators should cancel themselves out. The 3's cancel out, the 2's cancel out. If everything cancels out, you're left with a 1. 1 times y is simply y on your left-hand side. Do the math on your right-hand side. 5 times 3 in your numerator is 15. 6 times 2 in your denominator is 12. Another option is you could cross-cancel here and take out a 3. But since I didn't do that, I'll have to reduce here. Because I've got 15/12, but there is a common factor of 3 that I didn't take out earlier, I'll have to divide top and bottom by 3. And I get a reduced fraction of 5/4 as my answer. And then you would want to put that value back into your original problem to check and make sure it's accurate. All right, so let's look at these two examples. We've got -1/4 times x is equal to -5. Again, this problem is very similar. You've got a fraction multiplying to the variable you're trying to solve for. So we're going to take the reciprocal and multiply both sides by the reciprocal. So we've got -1/4 times x is equal to -5. Look at this fraction here and take the reciprocal. The reciprocal of -1/4 is -4/1. So we're going to multiply both sides by that. So we've got -5 times -4/1 here. We're going to make that into a fraction, okay, and simplify where we can. Notice that here the 4's cancel, the 1's cancel, and the negative and the negative, negative times negative is always positive. So we've got a +1 times x, which is just x, and that's equal to our right-hand side. Multiply your numerator. -5 times -4 is a +20, over 1 times 1 is 1, and x is equal to a +20. And then you could put that answer back in the original problem to check and make sure that that does indeed work. All right, now here, let's look at this decimal problem here. Here we've got -2.3 times b equals 9.2. Again, even though that's a decimal, we're going to solve it the same way. The opposite of multiplication is division, so we're going to divide both sides by -2.3. Left-hand side, negative divided by negative is a positive. 2.3 divided by 2.3 is 1, and a +1 times b is simply b. right-hand side, and this is probably a calculator problem, a positive 9.2 divided by a negative 2.3 leaves you with a negative 4. And that's your final answer. You would want to put that back in the original problem to check it. So now let's add what we learned in Section 2.1. We will use all 4 properties of equality, addition, subtraction, multiplication, and division, to solve the following equations, and opposite operations for addition and multiplication to solve the following equations. In general, you always want to do the following. Remove any parentheses first in the problem. Combine like terms on the same side of the equation. Get variable terms on one side of the equation and constants on the other. And the way you do that is you're going to use the addition and subtraction properties of equality. And then we're going to isolate the variable, which means we're going to use multiplication and division properties of equality. All right, so let's look at this top example. We've got 4 times the quantity 2x minus 3 plus 7 is equal to 3x plus 5. First step, always remove any parentheses. So we're going to take that 4 and we're going to use the distributive property to remove the parentheses by multiplying the 4 throughout. So 4 times 2x is 8x. 4 times minus 3 is minus 12, plus 7 equals 3x plus 5. All right, now always remember that we want to keep those sides separate when we're combining like terms. On the left-hand side, we've got a negative 12 and a positive 7 we can combine. You cannot combine the positive 5 on the other side of the equation, though, until you move it to the same side. So we've got the 2 like terms on the left-hand side we can combine. Minus 12 and plus 7 is a minus 5. Right-hand side, these are unlike terms, so we cannot combine them. I'm going to choose to get my variables on the left and my constants on the right. So I'm going to move that positive 3x by subtracting it from both sides of the equation. Positive 3x minus 3x from section 2.1 is 0. Left-hand side, 8x minus 3x leaves us with 5x's. Minus 5 equals 5. Okay, now I'm going to move my minus 5 right here to the right-hand side because I want my constants on the right. The opposite of subtraction is addition. And minus 5 and plus 5 is 0. 5x plus 0 is still 5x. So bringing that up here, we've now got 5x on our left-hand side. And on our right-hand side, 5 plus 5 is 10. All right, now we need to use the division property of equality. We have multiplication between the 5 and the x. I want to get rid of that multiplication step, so I'm going to divide both sides. 5 divided by 5 is 1, but 1 times x is still x. Right-hand side, 10 divided by 5 gives us a final answer of 2. Always a good idea to put that back in the original problem to check that. All right, 15y minus 8 equals 10 plus 9y. We want to solve for y, so we're going to choose to get variables on one side and constants on the other. Because many of the problems I've been doing, I've always been putting my variable on the left. I'm going to choose to put my variable on the right this time just to show you it doesn't matter. Okay, so I'm going to put all of my y terms on the right-hand side, which means I have to subtract 15y from both sides so that I can remove it from the left. If the 15y has been removed, 15y minus 15y is 0. 0 minus 8 leaves us with that negative 8. So on my left-hand side, I've got negative 8. Right-hand side, I've got the 10. And then 9y minus 15y will give us a negative 6y. All right, I want that 10 to be on my left-hand side with my other constant, so I'm going to subtract 10 from both sides. Negative 8 and negative 10 is negative 18, and that's equal to negative 6y on my right-hand side. 0 minus 6y is negative 6y. Divide both sides by negative 6, because the opposite of multiplication is division. And I'm left here with a final solution of y equals negative 18 divided by negative 6. Negative divided by a negative is positive. 18 divided by 6 is a final answer of positive 3. All right. Another couple of examples. 3 times the quantity 2 minus 5x plus 4 times 6x equals 12. Distribute your 3. 3 times 2 is 6. 3 times minus 5x is minus 15x. Plus 4 times 6x is 24x. And that's equal to 12. Combine like terms if they're on the same side of the equal sign. So we've got 6 and then minus 15 and a positive 24 is a positive 9x after you combine them is equal to 12. I'm going to subtract 6 from both sides because now I'm going to have my x on my left and my constants on the right. So that leaves me with 9x on my left-hand side. 12 minus 6 is 6. Trying to isolate x, trying to get x by itself. So now I've got a multiplication step that I need to remove with division. So divide both sides by 9. And I'm left with a solution of x equals 6 over 9, which is a fraction that must be reduced. If you take a 3 out of both top and bottom, 6 divided by 3 is 2, 9 divided by 3 is 3. And we have a final answer of x equals 2/3. For our bottom example, negative 2y minus 10 equals 5y plus 18. Now I'm going to choose to get my constant on the right-hand side. I'm sorry, my variable on my right-hand side, just to be different. So to move this negative 2y to the right-hand side, I'm going to need to add 2y to both sides. Negative 2y and positive 2y is 0. 0 minus 10 leaves me with a negative 10. Carry the negative 10 down. Here, 5y plus 2y is 7y. And I've still got that plus 18, which is an unlike term, and I can't combine that. Right now, I have chosen to put my constants on the left-hand side, so I'm going to subtract 18 to remove it from the right-hand side. Negative 10 and negative 18 is negative 28, is equal to 7y. Now we have a multiplication step. We need to get rid of that 7, so the opposite of multiplication is division. And that gives us up here, negative 28 divided by 7 is negative 4, is equal to y. Always a good idea to check that in your original problem. All right, so now we have 6x equals 5x minus 4. This problem actually is quite a bit simpler than some of the previous ones we did. I'm going to choose to get my x's on the left, so I'm going to subtract the 5x term to remove it from the right-hand side. That leaves me on the right-hand side with a negative 4. 0 minus 4 is negative 4. Left-hand side, those are like terms, so you can combine them. 6x's minus 5x's leaves you with 1x. And of course, 1 times anything is itself, so 1 times x is just x, and that's x equals a negative 4. Second example, 7 times the quantity 2x plus 1 equals 18x minus 19x. Let's distribute. 7 times 2x is 14x. Plus 7 times 1 is a positive 7. That's equal to, notice you have like terms on the same side, so we can combine those. 18x minus 19x is minus 1x, which is the same as just minus x. Remember, 1 times anything is itself, so if you want to drop the 1, you can. You don't have to. Totally up to you. Over here on the left-hand side, I still have 14x plus 7. All right, so I'm going to choose to move my x to the right-hand side. So I'm going to subtract 14x from both sides. 14 minus 14 is 0. 0 plus 7 leaves me with 7 on the left-hand side. Right-hand side, minus x or minus 1x. Minus 14x gives me negative 15 times x. And to solve, I'm going to have to get rid of that negative 15 because I want to isolate my x. So the opposite of multiplication is division by negative 15. And if we bring that up here, 7 divided by negative 15 is negative 7/15. And that's equal to our x value. That fraction cannot be reduced. And so that is our final answer in that particular example. All right, so let's look at these two examples. These are our final two examples for this section. We've got 5 minus 6 times the quantity 2 plus b is equal to b minus 14. Okay, need to get rid of our parentheses, so we are going to distribute here. Make sure you distribute the negative with it, or if that doesn't make sense to you, remember you can always change subtraction to addition of a negative, and that also emphasizes that you do need to distribute the negative sign with it. So we've got that 5 out in front, which doesn't have anything to do with the group. Minus 6 times 2 is minus 12, and minus 6 times a positive b is minus 6b, or plus a negative 6b if you like that better. Right-hand side, those are not like terms. You cannot combine them. Okay. Combine like terms on the same side of the equal sign. So here we can combine 5 minus 12, which gives us negative 7, minus 6b is equal to b minus 14. All right, I'm going to choose to get my constants on the right-hand side this time. So I'm going to add 7 to both sides. That leaves me with negative 6b on the left and b minus 7. Negative 14 plus 7 is a negative 7. B minus 7 on the right-hand side. Want my b's on the left-hand side, so that's a positive 1b, so I'm going to subtract it from both sides. B minus b is 0. On my right-hand side, then, I'm left with a negative 7. 0 minus 7 is negative 7. Left-hand side, negative 6b and a negative 1b gives us a total of negative 7b's. And if we divide both sides by negative 7 to isolate that b, b is equal to negative 7 divided by itself is a positive 1. And finally, negative times the quantity 4a minus 7 minus 5a is equal to 10 plus a. Remember from earlier sections, anytime you have a negative out in front of a parenthesis, that negative has to apply to everything in the group. Okay? Another way to think about that is you can think about that as a negative 1 if that makes more sense to you. But either way, you do have to distribute that negative sign throughout that group when you're removing those parentheses when you're distributing. So negative of a positive 4a, or negative 1 times 4a, gives you a negative 4a, and negative 1, or the negative of a minus 7, is a positive 7. Negative times negative is a positive. Minus 5a is equal to 10 plus a. Combine like terms on the same side if there are any. Negative 4a and negative 5a is negative 9a plus 7 equals 10 plus a. I'm going to choose to subtract 7 from both sides. get my a's on the left-hand side. So I've got negative 9a is equal to 10 minus 7 is 3 plus a. I want to move that a, so subtract a, which is the same as 1 times a, if you want to put a 1 ahead of that. Negative 9a and negative 1a is negative 10a, and that's equal to, on the right-hand side, positive 3. Trying to isolate a, so we're going to divide both sides by negative 10, and a is equal to negative 3/10 as our final answer. This brings us to the end of Module 6, Section 2.2 material. You should now complete the homework for Module 6, Section 2.2, found in my math lab. When you have successfully completed the above homework, you may proceed to the Module 6, Section 2.3 video.